Chapter 7, we will talk about linear momentum. So what is momentum? Well, let's start off with what we actually know. We know F equals ma, where m is the mass and a is the acceleration. So now, can this F be also expressed in something else? And the answer is yes. It also can be expressed in something that's called momentum and time. So that F can also be written as delta P over delta T, where P is the momentum of the object. So the resultant change of momentum of an object is equals to the force acting on it and in the direction of that force. Newton actually did not express his first second law of motion in terms of just ma, but he also expressed it in terms of momentum. And for when he was expressing it in terms of momentum, he called it the quantity of motion. Linear momentum. The momentum of a body is then therefore defined as m times the velocity. Note, p is a vector quantity because velocity is a vector quantity. Linear momentum is associated with how a mass moves along a straight path. A force can change the linear momentum of a mass. So if I was to give you in 4 lines what linear momentum is, I would give you that in this form. Momentum equals P equals mv, where P is the momentum and v is the velocity. Since v is a vector quantity, P has to be a vector quantity. The unit of momentum is kilograms meters per second, and there is no derived units for momentum. Like, for example, kilograms meters per second squared is called a Newton, which is a unit of force. Momentum does not have a derived unit. Another important concept to learn is the conservation of momentum. Consider 2 interacting bodies, one with mass m1 and one with mass m2. The change of momentum during this collision of the 2 bodies is equal and opposite. The total momentum is conserved during this interaction such that the momentum lost by one object is gained by the other object. So in a nutshell, you can put in delta P equals 0. Impulsive forces. An impulsive force is defined as a force applied for a very short interval of time, as compared to the time of observation of a system. For example, for force during the collision of a bat striking a ball is going to be called an impulsive force. It is a large force, but it acts on for a very, very short interval of time. So there can be 2 kinds of impulsive forces. One of them is a ball hitting a stationary bat, and the other one is a ball hitting a moving bat. So in one case, one of the objects is stationary, and in the other case, both of the objects are moving. By definition, impulsive forces can be given as delta P equals F, which is a force, times delta T. Impulse momentum theorem is one of the most important theorems in physics, which is given mathematically as J, which is equals to change in F over time, which is equals to the change in momentum. So in other words, the impulse of the net force acting on the particle during a given time interval is equals to the change in momentum of the particle during that interval. Since this is a vector quantity, we now need to make sure that we can define it in 3-dimensional space in terms of x, y, and z. Note that the formulas themselves do not change, but their variables change as you go from one coordinate axis to another coordinate axis. Now let's do an example for momentum. A force of 30 newtons is applied for 5 seconds to each of the 2 bodies of different masses, mass 1 or mass 2. Take mass 1 to be less than mass 2. Which mass has the greater momentum change? B. Which mass has the greatest velocity change? C. Which mass has the greatest acceleration? Example 2. An object of mass 3 kilograms is allowed to fall from rest under the force of gravity for 3.4 seconds. What is the change in momentum? Ignore air resistance. Now the question gives us a force of 30 newtons is applied to two masses. One is mass M1 and one is mass M2. And it says take M1 to be less than M2. So M1 is smaller than M2 and force of 30 newtons, let's say, is being applied in both cases, right? So what is happening? The question 1, it asks which mass has the greatest momentum change. So now we have to find the change in momentum for both of these masses. Well, what do you think? What do we know about the change in momentum? I have change in momentum equals F dot delta T. And assume that both of them, the time is the same that it takes to apply for both of them. So in this case, since the force is same in both cases, and T is the same in both cases, because the time interval that the force is applied is the same, change in momentum for M2 is the same as M1. Okay? So that's part A. Part B, it asks which has the greatest velocity change. So change in velocity, right? We know P equals mv. Now since P2 is the same as P1, and we know that, this means that P1 when acts on M1v and P2 acts on M2v. Agree? Okay, so that means if the same momentum acts on a smaller mass, it will give me a larger velocity. So that means V1 will be much larger than V2 if M1 is much smaller than M2. Okay, so the change in velocity will be, velocity 1 will be much bigger than velocity 2. And part C, it says which is the greatest change in acceleration. This will be A is dv or delta V over delta t. So that means A1 equals delta V1 over delta t, and A2 is delta V2 over delta t. So since V1 is greater than V2, this implies A1 will also be greater than A2. In this question, it gives us the object's mass as being 3 kilograms, and it's allowed to fall from rest, which basically means its initial velocity is 0, and the time that it takes to fall is 3.4 seconds. So what it's asking me is, what is the change in momentum? Delta P is what I am looking for, right? The change in momentum as this ball falls. Okay, we know delta P is m delta V, okay? That means in order to calculate this, I should have Vf minus Vi, final and initial velocity. V naught or Vi, whatever you want to call it, is actually equals to 0. So that means all I need is the mass of the object and the final velocity of the object to calculate P. Now how do I find the final velocity? Well, this is what my job is. Okay? What do we know? If an object falls, here's my object, and it's falling, right? What are the forces acting on it? Well, it's technically a free fall, so the only force that's going to be acting on it is gravity. Okay? So what other information does that question give me? Well, I know that it gives me initial velocity 0, gives me a time, and gives me acceleration due to gravity. So now I can go back to my equations of motion and solve for that. Okay, this means this is equals to 0. Vf is going to be gt, which basically means is Vf is going to be 9.8, oops, sorry, I forgot the minus sign because it's pointing downwards, 9.8 times t, which is 3.4 seconds. Okay? Plug it into your calculator and your velocity value comes out to be minus 33.3 meters per second. Okay? Now what does this minus sign mean? This minus sign means is that this velocity is downwards, which it should be if it's falling down. Okay? Once we have that, I can plug that back value in here. I already know what the mass is, so I can plug the mass in here and the velocity in here and be able to solve it. So my mass is now equals to 3 kilograms, and my velocity was minus 33.3 meters per second. I can solve it, and my answer comes out to be minus 100 kilograms meters per second. And that is going to be my change in momentum from this ball starting at this point and ending up at this point. The next question is, what average force is necessary to bring a 50 kilogram sled from rest to 3 meters per second in a time of 20 seconds? Assume that the ice is frictionless. So in this question, it's asking me for average force, okay? Giving me the mass is equals to 50 kilograms. The initial velocity is equals to 0 meters per second because it says it's at rest. Final velocity is 3 meters per second and in a time of 20 seconds. So now I have to figure out what I actually know that's going to be useful. So I know that all of this is telling me delta P over delta T because it's giving me a time and it's giving me all of this information. So delta P is now going to be m delta V divided by delta T, right? So that means my V average is going to be mass, final velocity minus initial velocity divided by the change in time, okay? In this case, my mass is 50, my final velocity is 3, my initial velocity was 0, and the change in time is 20 seconds, and my answer comes out to be 7.5 newtons. So this is the average velocity that I need to have in order to make my 50 kilogram mass run from 0 to 3 meters per second. Now, if I was to ask you a slightly different question, and I was to say that now change this T2 to be 2 seconds. Now, how much more force will I need in order for this T to now become 2 seconds? What you would do in that case is replace this 20 with 2 seconds, 50, 3 minus 0 divided by 2. And what would your answer be? Yes, 75 newtons. So you have just increased the amount of force needed in order to accelerate it by 10%. So it all depends on the time that you are allowed.